Hello and welcome to yet another lecture on Basic Electrical Engineering. Paper code ESEE 101. Myself, Prathita Roy, Assistant Professor of Dr. Sudhir Chandra Institute of Technology and Sports Complex, Department of Electrical Engineering. Today, my topic is types of wires and cables and switch fuse unit or SFU. Lesson objective. After the end of this topic, students will be able to understand the concept of different types of wires and cables and working of switch fuse unit. So the wires and cables. So a wire is a flexible strand or a rod of metal that is used to carry current. The wires must be made of good conducting materials to reduce the power loss due to resistance. The best conducting material is silver, whose resistivity is 1.59 into 10 to the power minus 8 ohm meter at 20 degrees centigrade. But as silver is very costly, so it is used only for special applications. The next best conducting material is copper, whose resistivity is 1.72 into 10 to the power minus 8 ohm meter. The most commonly used conducting material in India is aluminium, whose resistivity that is varies between 2.65 into 10 to the power minus 8 ohm to 2.82 into 10 to the ohm meter to 2.82 into 10 to the power minus 8 ohm meter. Apart from the good conductivity, the material used for wire must be ductile, which means that it can be stretched to a good length without breaking. Moreover, the material should be resistance. Resistance, the bad effects that shorten the life of a conductor as the temperature of a wire that is increasing while carrying the current, the wire that must be able to sustain the fluctuation in temperature. Generally, an electrical cable is stranded, that is, a large number of small diameter wires that are used so that it becomes more and more flexible, but more strands that increase the manufacturing complexity and also the cost. The lower number of strands is usually 7 on in the middle with 6 surrounding it in close contact. That is 1 in the middle and it is surrounded by 6. The next level, the total number of strands is 19, where another 12 strands is placed on the top of 7 same 7 and the 12 strands are placed on the top of 7 to make it 19. 12 plus 7, that is equal to 19. The cables that are usually designed by the number of strands, diameter of each strands, the diameter that is of each strand, and insulation that is provided. For example of 19 by 03 VIR cable means the cable that is consists of 19 strands of wire of 0.3 millimeter diameter of each, and insulation provided is vulcanized India rubber. The current carrying capacity, again the 19 by 0.3 VIR cable means the cable that is consists of 19 strands of wire, 19 strands of wire of 0.3 millimeter diameter of each, and the insulation that is provided is vulcanized India rubber. The current carrying capacity of each cable can be varied by varying the number of strands and diameter of each wire. A cable that is comprised of three major components: conductors, insulation, and protective jacket. The following three factors that is determine the construction and material of the cable: current carrying capacity, which determines the cross section of the conductor; working voltage, which determines the thickness of insulation; environmental conditions such as chemical or sunlight exposure; environmental conditions that is such as chemical or sunlight exposure; temperature, water and mechanical impact, which determine the form and composition of outer cable jacket. So the following three factors, that is conductors, insulation and protective jacket, which determines the construction and material of the cable. So wires that is made of aluminum conductor, aluminum conductor, that is known as AAC, are not mechanically sufficiently strong for construction of long span lines. To add the mechanical strain to the wire, aluminum conductor steel reinforced, that is ACSR, aluminum conductor steel reinforced cable is used in overhead power transmission lines. The outer strands are pure aluminum conductor, which have good conductivity and low weight. The central core is made of steel, which have good. The central core that is made of steel, that which increase the mechanical strength of the cable, that I have already told. In order to increase the mechanical strength of the cable, the central core that is made of steel, as steel has a lower elastic and inelastic deformation, inelastic deformation lower due to mechanical loading, that is wind and ice loading, and lower coefficient of thermal expansion under current loading. ACSR conductors allow significantly less sag than all aluminum conductors. While calculating the current carrying capacity and resistance only the conductivity of the aluminum conductor is taken into the account. So in order to give the mechanical strength of the cable, the core that is made of steel, but the current carrying capacity and resistance, which is determined only the conductivity of the aluminum conductor, that is taken into the account. Another is the ACAR. ACAR, the name that it suggests that aluminum conductor alloy reinforced. Aluminum conductor alloy reinforced. But wires are also used nowadays which have a central core of alloy of aluminum, which is surrounded by conductors that is made of aluminum, compared to ACSR conductor of same diameters. This conductor has better conductivity and same strength to weight ratio. A triple AC, that is aluminum alloy conductor, triple AC, that that is aluminum alloy conductor, AU aluminum alloy conductor, that finds application in urban areas as they have good conductivity and tensile strength. So this is the different types of wires and the cables that is used in general application of electrical engineering, or say the power transmission, the general wires and the cables that use. So now I am going to discuss about some effect on the cables and the wires. The first that is the skin effect. The name that is suggests skin means the upper surface. In our body, the skin is the upper surface. So skin effect means the effect that is occurred on the upper surface is called the skin effect. So in a current carrying, in a wire that is carrying DC current, the current is uniformly distributed throughout the whole cross section of the wire. But when an AC current flows, there is a tendency of the current to flow near the surface of the wire. That I have told. The skin effect means when an AC current flows, there is a tendency of the current to flow near the surface of the wire. This is because a cylindrical element near the center of the wire is linked by both internal and external flux. On the other hand, an element that near the surface of the wire is linked by the external flux only. Hence, the inner element that possesses greater self-inductance than the outer element and offers greater inductive reactance than the outer one. Therefore, the current has a tendency to crowd towards the surface. Again, the current has a tendency to crowd towards the surface, or say the skin of the wire. This phenomenon is known as skin effect. Because the inner element that is possesses a greater self-inductance than the outer element, and offers greater inductive reactance than the outer one. As a result, the tendency of the current to crowd towards the surface or skin of the wire. This phenomenon is also known as skin effect. This results in decrease of effective cross-sectional area of a wire, where the effective resistance of a wire while carrying the alternating current that is increases. Skin effect that increase with increasing frequency, wire diameter and permeability. So the effect result in decrease of effective cross-sectional area of a wire and the effective resistance of a wire while carrying alternating current, and the effective resistance of a wire while carrying the alternating current that is increases. So the another effect is known as proximity effect. When two or more wires that is carrying AC current are in close proximity to one another, the electromagnetic field created by each wire that is interact with each other. As a result, the current through each wire will be redistributed. The current will be concentrated in the areas of the wire farthest away from nearly wires carrying current in the same direction. So the result is the current will be concentrated in the areas of the wire that is farthest away from nearly wires carrying current in the same direction. The result is in increase of effective resistance of the wire. So another part is the materials that is used for insulation purpose for the wires and the cables. So the insulation is provided in the cables and wires to prevent the current coming in contact with other conductors. So the general materials that is used for the insulations are vulcanized India rubber or PIR. The the pure rubber has good insulating properties. It is very soft and liable to get damaged due to rough handling. Moreover, it is readily absorb moisture and it cannot withstand high temperature. Hence, pure rubber that is mixed with material such as zinc oxide, red lead, sulfur, etc., and then applied to the conductor and is heated to a temperature of about 150 degrees centigrade. This process is called vulcanization. This process is called vulcanization, and the product is called vulcanized India rubber or VIR, vulcanized India rubber. So it has a greater mechanical strength and durability than the pure rubber. VIR insulation is used for low and moderate voltage cables. Sometimes in VIR cables, a sheet of lead or similar alloy is provided over the rubber insulation. This sheet is strong enough to withstand rough handling and landing. Also, it provides good mechanical protection and prevents entry of moisture from atmosphere to into cable, from atmosphere into the cable. So the another is the polyvinyl chloride, or we all know that is PVC, polyvinyl chloride. The PVC is a plastic synthesis resin and is obtained from the polymerization of acetylene. It is obtained in the form of white powder and compounded with certain materials known as plasticizers. Plasticizers. So it is compound with certain material that is known as plasticizers, which are liquids and high boiling point. PVC cables are flexible and waterproof. They are preferred over VIR cables in extreme environmental conditions such as cement factory or ceramic chemical factory, as PVC is in as it is generally used in the chemical factory or the cement factory, as PVC is inert to oxygen and almost inert to many acids and alkalis, and almost inert to many acids and alkalis. But the resistivity of PVC is less than of rubber, and hence the thickness of the PVC insulation has to be larger than that of rubber. PVC insulated cables are generally used for domestic lights and power installations for low and medium voltage. Another is the impregnated paper. These are chemically pulped paper that is made from wood chippings and impregnated with paraffinic or impregnated with paraffinic or naphthenic material. They have the advantage of low cost, high dielectric strength, and high insulation resistance. The main disadvantage of this type of insulation is that it absorbs moisture, that is, lowers the insulation resistance of the cables. Hence, paper insulation cables are always provided with some protective covering and never left unsealed. They are used in places where there are few joints in the cables and can be used for distribution at low voltage areas, means the low voltage congested areas, but the joints are provided at the terminal apparatus. So another is the varnished cambric. So the varnished cambric is a cotton cloth impregnated and coated with varnish. It is not moisture resistant and hence a metallic covering is always provided. The dielectric loss is higher than that of impregnated paper insulation. They are suitable for use in hot and dry environment such as steel plants, foundries, furnaces, rolling mills, industrial substations, and others. They are also used in transmission of high voltage power over short distance. They are also used in transmission of high voltage power over short distances. So another part of our discussion is the switch fuse unit or SFU. In industry, a fuse is used an electrical safety device that operates to produce short circuit protection of the concerned electrical circuit. The fuse is essentially an alloy strip or wire that melts when short circuit current passes through it, thereby interrupting the short circuit current and disconnecting the faulty current. It is basically a sacrifice device that we can say and was operated it must be replaced or rewired. I mean, it can be replaced and rewired. So in house, fuse in house, in switch fuse units and SFU serve both the function of switching and also the protection of the circuit. The SFU that contain and sheet steel enclosure that contain the mechanical switching mechanism, that is the manual, and the rewirable fuse are of two types fuse. There is the first one, that is the second one, but the first one is known as fuse is mounted at stationary part of the SFU, and the second one, that is fuse is mounted on the moving part of the SFU. It is clearly seen that. One, the fuse is mounted at the stationary part of the SFU. It is clearly seen in this figure. And another, the fuse that is mounted on the moving part of the SFU. So, the moving part SFU that we have already seen, that is not preferred any longer. In industry, that we are generally use the three-phase combination of SFU, that is triple pole switch, triple pole, that is three pole with neutral SFU, three pole with neutral SFU. Usually, the three-phase systems, the SFU is called the TPN SFU or triple pole with neutral SFU, and it is clearly seen in this figure. Three fuses that are mounted at the incomer side of the SFUs. Three fuses that is mounted at the incomer side, incoming line of the SFU, that is the load 1, 2, 3, the ABC, three phases, and that is the incoming line, and the three fuses are mounted, that is fuse 1, 2, and 3 in the incomer side of the SFU, while a link that is used for continuity to the neutral. This is the N stands for neutral, and a link that is used for the continuity of the neutral, and this is the load part. This is the triple pole with neutral SFU, TPN SFU. For single phase, rewirable SFU is commonly used for the domestic supply, is known as SPN SFU or single pole and neutral SFU. SFU in electrical circuit is used distributing power and protecting electrical devices and cables from damage due to the fluctuation and fault in addition to the switching requirement. This is the general conception and application of switch fuse unit or SFU. Thank you.